Hi everybody, and welcome to our volume of a Gas at STP Lab. This is going to be the lab that you are looking at. All right, the goal or the purpose of this lab is to verify that 1 mole of a gas at STP will have a volume of 22.4 decimeters cubed or liters. All right, so as you watch this lab, I am going to talk you through the procedures as Maurice does it. We're going to be seeing a reaction between magnesium and hydrochloric acid. All right, that is a single replacement reaction, so keep that in mind as you're writing the balanced equation for it. All right, you are going to be collecting the gas that is produced, which is hydrogen gas, and you're going to be collecting that over water. So please remember from our last unit that when you collect something over water, the pressure inside, all right, is the dry gas, the gas we care about, the hydrogen, and the water vapor. So you're going to have to look up what the water vapor pressure is at our recorded temperature. Okay, so you're going to go through as far as the data is concerned, watch the video, record all of the information. You're going to write that balanced equation. Again, it's magnesium plus hydrochloric acid, all right? And that is a single replacement where we're producing hydrogen gas. All right, so as you flip your sheet over, let's look at number 2. Correct the gas volume to the volume it would be at STP, standard temperature and pressure. Please remember the purpose of this gas is to verify that 1 mole has a volume of 22.4. Therefore, we cannot use the ideal gas equation with this. All right, I know that we just learned about the ideal gas equation, but we cannot use it in this lab because we are pretty much trying to verify that the ideal gas equation really does work. So we cannot use it. So that's why I have no ideal gas law written after number 2. Instead, for number 2, I'm going to give you a little hint. You are going to use the combined gas law. So again, on the back, number 2, you're going to be using the combined gas law. Number 3, you're going to determine the number of moles of hydrogen gas that was produced from the reaction. Again, no ideal gas law. For this one, I'm going to tell you, you're going to be doing a stoichiometry problem where you stop and you solve for moles, but it will be a factor labeled stoichiometry problem. No ideal gas law for number 3. And please make sure that you look very carefully at your notes where it states what Avogadro's law is from your data. So you have so many moles, so that's from number 3, of hydrogen has a volume of whatever the volume got from number 2 in liters. You're going to come up with your ratio, and then using 22.4 as the known, you are going to do your percent error. All right. Good luck on the lab. Have fun watching, and have a great day.
Hi, welcome to our lab.
All right, so this is an analytical balance that Maurice is going to be using today, and we use this for things that have a very light mass. So it's already zeroed, we've already tiered it or zeroed it. So Maurice is going to go through the side. As you can see, there's tops, bottoms. You can just go through the side and find the mass of his magnesium ribbon. All right. So this is in grams, and we're going to go ahead. It's very common with these analytical balances to have that last digit kind of change a lot. So you can kind of just choose, there we go, what that last digit is going to be. All right, so now we are actually in a lab at Whitman, and we are going to show you how to do this reaction. So the first thing Maurice is going to do is he is going to take that magnesium ribbon that we already know the mass of. He is going to attach it to the end of this stopper. You just fold it once, and that's good to go. You can just leave that. Great. He's then going to take the piece of equipment there that is actually called a eudiometer, which is a fancy way of calling it a gas collecting tube. So we are going to actually collect the gas that we produced from this reaction in this tube. So the first thing Maurice is going to do is he's going to take 10 milliliters of hydrochloric acid and carefully pour it into the gas collecting tube. All right, great. He's now just going to take water, and that's what's in this beaker, okay? And he's going to fill the gas collecting tube all the way up with water. We don't want any air in this because we don't want air to be the gas we care about. We want it to be, all right, so here, I'll hold that. You refill the water. The water's, that's the gas, water. There we go. Okay, yeah, got it?
Yep.
Okay, all the way so it's spilling over. keep pouring. The acid, remember, is in the bottom, and it's not gonna come out. All right, perfect. Now you're gonna take the cork with the magnesium on the end, and we are gonna just stick it in there. It's gonna spill out, that's fine. Gently, gently, it's glass, okay. All right, so now what Maurice is gonna do, we have a trough here filled just with water. He is gonna take the gas collecting tube, he's gonna invert it, so all the way upside down. Great, and we're gonna now just clamp it here. Okay, and now you can actually see, hopefully we can see this. Why don't you put the white paper up behind? You can see the acid kind of making its way down. Okay. And it's gonna touch the magnesium metal, which is there at the bottom. And in a little bit, we are gonna see bubbles form. Okay. So Maurice, why don't you tell people when you see those, start seeing bubbles form?
Oh, there's a few.
Okay, there's a few. And we just want to note, while Maurice has the paper up, this is how the gas collecting tube works. So this is going to tell us exactly, all the way to the top, please, paper. This is going to tell us exactly how much gas we end up producing. So I think our acid is still working its way down. All right, we're going to come back in a couple minutes and show you the gas that is produced. All right, so this is going to take several minutes, but I just wanted you to see that gas being produced. All right, you can see it bubbling and it is being collected in the top of the tube. All right, as you can see, we're really forming some gas bubbles now. All right, and they are starting to collect in the top of the tube. All right, so while we are still collecting our gas, Maurice is gonna go ahead and take the temperature of our water inside, and I'm gonna actually film it so you can see it. There we go, so there is our temperature in Celsius. All right, also, we are going to assume that the pressure inside the tube is the same as the pressure in the room. Here is the pressure for the room today. All right, so this is something you look up actually on like the weather station. The pressure is 30.08 inches of mercury. Again, we are in the United States, so Google will give it to you in inches. You need to look up the conversion and convert that to the proper units for our lab. Also, please remember, okay, this gas, we are collecting this gas over water. So the pressure in there, that 30.8, is the water vapor and the gas we care about. So you need to look up what the water vapor pressure will be at our specific temperature and subtract that from the barometric pressure. Okay, so the reaction has completely stopped, and now we have our desired gas all in the top of our gas collecting tube. And again, this does start counting 1 and then down. So as far as finding, I'm gonna make sure that this, yep, right there, zooms in. That is the volume of our gas. All right, take care.